Rays make angles. Turns have degrees. Measure the opening.
Out on the dawn savanna, survival requires constant vigilance. Suri the meerkat stands tall on her termite mound, constantly turning to scan the horizon for danger. But measuring her turns presents a problem. Turning is a continuous, invisible physical action. She leaves no footprint in the air when she twists. We need a way to quantify an action that leaves no physical trace. The wise math Sheba sits nearby, looking on as an imaginary circle projects onto the ground, centering itself perfectly beneath Suri's paws. Looking down at this ground circle, we cut the entire ring into exactly 360 equal slices. Each tiny wedge is a 1-degree angle. By overlaying this grid onto the savanna, her movement has a track. We've transformed invisible motion into something we can count. The maximum limit of a turn is a complete rotation, spinning until you face your exact starting point again. Because this full turn sweeps through every available wedge in our circle, the measurement is the sum of all its parts, 360 degrees. But most turns are shorter. Watch as Suri pivots away from the waterhole on her left to face a dead acacia tree to her right. This visual sweep between the waterhole and the tree represents exactly 1/4 of the circle. To find the measure, we divide the whole 360 by 4. 360 divided by 4 is 90. This quarter turn covers 90 of our 1-degree wedges. We can calculate any major shift in direction simply by dividing the 360-degree hole by the fraction of the circle she has turned. Sometimes a shift in focus is more subtle, a slight adjustment in posture to check a rustle in the tall grass. For these microturns, fractional division is less practical than the primary mechanism, counting individual 1-degree wedges. This reveals the mechanism at work. An angle that turns through n 1-degree wedges measures exactly n degrees. In this case, Suri covered exactly 30 wedges. Therefore, her turn measures 30 degrees. Whether we are scaling down from the full 360-degree circle or counting up from a single wedge, the logic of the turn remains consistent. Looking across the savanna, we see these rules overlaying the environment: the 360-degree full ring, the 90-degree quarter arc, and the 30-degree microturn. To find any measure, cut the circle into 360 equal wedges, each one a single degree, and count the wedges you turn. As the wise math Sheba trots off through the grass, every turn Suri makes is now a matter of counting wedges. Consider this: if Suri turns through exactly 1/6 of the full horizon ring, what is the degree measurement of her turn? Counting turns as wedges of a circle is what allows us to map the savanna and eventually the rest of the world.
1 turn is 360. Quarter turn is 90. Degrees measure turning.